Hey guys, welcome back to Eureka, and in this video I'll be teaching you how to do the binomial theorem section and what is the binomial theorem. Before we get into it, binomial theorem tells you to expand a binomial raised to any power. Let's take the simplest binomials, a plus b squared, and you know the expansion for this, the grade 7 identity. Let's say you had a plus b all raised to the power of 3. Well, we can expand this out, and you guys know how to expand this. It's grade 7 material. But now, what if we had a plus b all raised to the power of n being a very big number, or let's say power of 5, power of 6, power of 100. Now, the binomial theorem tells you, or it states, that this expansion is equal to sigma. By the way, this means expansion when you expand the binomial. Sigma as k goes from 0 to n. K is a dummy variable, it keeps on changing. N combination k, a to the power of n minus k, a being the first variable, multiplied by b raised to the power of k, b being the second variable. Now that I've stated the binomial theorem, let me tell you how it works. Let's say we had a plus b squared again, and we want to use the binomial theorem to expand. In this case, n is equal to the power of 2, right? So let's rewrite this in terms of the power of 2. So it's going to be k goes from 0 to 2, right? 2 choose k. 2 combination k means 2 choose k. A raised to the power of 2 minus k, b raised to the k, right? So let's start. K goes from 0, so the first term is going to be 2 combination 0, a to the power of 2 minus 0, b to the power of 0, right? Plus. Now k becomes 1, and we're just gonna rewrite a to the power of 2 minus 1, b to the power of 1. And then finally k becomes 2, and it's gonna be 2 combination 2, a to the power of 0, or a to the power of 2 minus 2, which is 0, b to the power of 2. Right, guys? So we can simplify this, and this becomes a squared. We can simplify this, and this becomes 2ab. We can simplify this becomes b squared. And as you can see, using the binomial theorem to expand this out gave us the same answer as the normal expansion when we just multiplied a plus b by itself. So let's say we had a plus b to the nth power, and let's say we want to use the binomial theorem to expand it. A plus b raised to the power of 5. This is a different example, and let's just choose a higher power. It's going to be a to the power of 5 minus k, of course, nk here. Sorry about that. Let's just rewrite it all. N goes from 0 to 5, let's say. N choose k. In this case, n is equal to 5, right? So we can basically do this and put 5 instead. A raised to the power of n minus k. And as we said, n could be replaced by 5. B raised to the power of k, right? Let's start. It's going to be 5 combination 0, a to the power of 5 minus 0, b to the power of 0, right? And then k becomes 1, and you just substitute the numbers. And then you go on and on and on until you reach 5 combination 5, a to the power of 5 minus 5, right? A is raised to the difference of these two numbers, b is raised to the power of 5. And this is the binomial theorem. Now, let's do some activities from the book so you guys can understand it. Let's do activity 2, page 24. Example 2, page 24. It tells you that you have 2x plus 3 all raised to the power of 5, right? Let's use the binomial theorem to expand this out. And now 2x is our first term, right? 2x is raised to the power of n minus k. Now n is equal to 5, so we can basically substitute these by 5, right? And in this case, b is equal to 3, and 3 is raised to the power of k. Let's expand this. So it's going to be 5 combination 0, 2x raised to the power of 5 minus 0, which is 5, and 3 is raised to the 0. Anything raised to the 0 is 1, right? And let's just write this again. 2x raised to the power of 5 minus 1, which is 4. b is raised to the second number. In this case, b is 3, so it's 3 raised to the power of 1. And we have 5 combination 2x raised to the power of their difference. 5 minus 2 is 3, multiplied by 3 raised to the power of 2. Right, guys? And you see the pattern again. Let's just write this all out. Well, yeah, and this is basically how you use the binomial theorem. Plus 5 combination 5, 2x raised to the power of 0, 3 raised to the power of 5. Right? Let's just expand the first term. 5 combination 0 is equal to 1. So we can say 2x raised to the power of 5 plus 5 combination 1 is equal to 5 multiplied by 3, right? Because we have a 3 here. And then we have 2x raised to the power of 4 plus, finished with the first term, finished with the second term. We have 3 squared, which is 9. 9 is multiplied by 5 combination 2, which is equal to 10 times 9 multiplied by 2x raised to the power of 3, right? And you can expand this out using a calculator and you will get the answer. So this is how you use the binomial theorem. Now let's do a bit more, trickier exercises from the book. Let me just clear out the screen. Let's say you had 3x minus 4 all raised to the power of 4, and you were asked to find the coefficient of the term that has x cubed in it. They're not telling you expand all of the binomial, they're just telling you to find the coefficient. Coefficient means the number that's supposed to be here. So if we had 1x cubed, the coefficient is 1, So they want the coefficient of the term that has x to the power of 3. So let's rewrite this in binomial notation, but in this case we're not going to expand the whole thing out. We just want the term that has x cubed in it. So we know that n is equal to 4, so we put 4 there. And now we put k. We don't know what k is, right? And then x is raised to the power of 4 minus k. And the second term, 3x, is raised to the power of 4 minus k, because our first term is 3x. And the second term, which is minus 4, is raised to the power of k. Now, what do we know about 4 and k? What's the relationship between them? We know that 4 minus k is supposed to be equal to this number, right? So in this case, you can solve this, and k is equal to 1. Let's substitute 4 combination 1. 3x raised to the power of 3 minus 4 is raised to the power of 1. And that should be your answer. So it's going to be 4 multiplied by 27x cubed multiplied by minus 4, right? And you can use a calculator to figure this out. And your answer should be equal to minus 216 x cubed. So what's the coefficient? Minus 216. That's how you solve it. Let me just clear out the screen again. Now I want to show you an easier way of expanding a binomial using the Pascal's triangle. Now, how do we use the Pascal's triangle, and what is the Pascal's triangle? The Pascal's triangle gives you the coefficients of all the terms when a plus b is raised to the power of n. What does that mean? That means, let's say you had a plus b raised to the power of 4, for example, and you wanted to expand this out using the Pascal's triangle. So how would you do it? Let me show you. You take the first term and you repeat it 5 times in this case. You know why you repeat it 5 times? Well, because the binomial is raised to the power of 4. So every time you have a binomial raised to the power of n, the amount of terms you're going to have are n plus 1. So in this case it's 4, so 4 plus 1 is 5, right? And then you do the same thing with the second variable, and you put it beside the first variable, like that. Let's just make more space, like that. And now you need to raise the first variable to the power of 4 and then go in decreasing order. So we have 4 here, 3 here, 2 here, 1 here, and 0 here, right? And then with the second variable, you raise it to the power of 0 first, and you go in increasing order in this case. Now, you can obviously see there's something missing. They're all pluses because this number is a plus, right? But now you can see there's something missing, the coefficients. Now, how do you find the coefficient? You need to use something called Pascal's triangle. What Pascal's triangle gives you is all the coefficients of all the terms. So let me show you. Let's just go to a different page, and I'll show you how the Pascal's triangle works. So let's say you had a plus b raised to the power of 0. Then this is equal to 1, right? The coefficient is 1, so you put 1 here. A plus b raised to the power of 1, well, this is equal to a plus b. What are the coefficients? 1 and 1. A plus b squared is equal to a squared plus 2ab plus b squared. What are the coefficients? 1, 2, and 1, right? So you list them down. 1, 1, 1, 2, and 1. A plus b all cubed, well, this is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed, right? What are the coefficients? You have 1, 3, 3, and 1. So you list them down. 1, 3, 3, and 1. And now, let's say you want to find the coefficients of a plus b to the power of 4, and you don't want to expand it. Well, you simply just move the branches out. You draw branches like this, and you find the sum of the numbers. First of all, a plus the number to the left of a. There's nothing to the left of a, so it comes down as 1. Now, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And 1, again, there isn't a number to the right of 1, so we just assume it's 0. Now, these are all the coefficients of a plus b to the 4th power. What does that mean? Now, if you wanted to expand a plus b to the 4th power, I memorized it. It's going to be a plus b to the 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the power of 4. What can you notice? You see all of these coefficients, 1, 4, 6, 4, 1. Well, we have them here, 1, 4, 6, 4, 1. The Pascal's triangle gives you all the coefficients without listing the variables. So let's go back to this page. And let's just put in the coefficients in the same order, right? This is it. Now, to give you a general idea of this, so let's solve another binomial using the Pascal's triangle. Let's say we have a plus b raised to the power of 5. Let's draw Pascal's triangle here. We said let's make more space. We said we have 1, 1, 1, 1, 2, 1, right? And then this extends. This becomes a 3, this becomes a 3, and this becomes a 1. And this expands, becomes 4, 6, 4, 1, right? And then this expands, becomes 1, 5, 10, 10, 5, 1, right? This is a plus b to the power of 0, a plus b to the power of 1, a plus b to the power of 2, a plus b to the power of 3, a plus b to the power of 4, a plus b to the power of 5. Now we have a plus b to the power of 5, so we stop here. You take the coefficients, which are 1, 5, 10, 10, 5, and 1, right? And what did I tell you? How do you solve this? Well, if you have 5 terms, if you have a power of 5, then you're supposed to have 6 terms, right? So we're going to list them down. AB plus AB plus AB plus AB plus AB plus AB, right? 1, 2, 3, 4, 5, 6. And as we said, A takes the highest power and it keeps on going down, descending order, right? And then B goes in ascending order, like this, right? And then we simply take these numbers and we plug them in. 1, 5, 10, 10, 5, and 1. And this is the expansion of a plus b to the power of 5 using Pascal's triangle. So let me show you another example before ending this video. Let's keep this Pascal's triangle here, like this, right? And let's erase all of these. And let's say you had a plus b to the power of 6, right? A plus b to the power of 6, right? So let's continue with this thing. So a plus b to the power of 6. All of these are powers. You don't need to worry about them. We have 1 goes here, 6 comes here, 15 is here, 20, 15, 6, and 1. By the way, guys, if you notice something, this is repeated on both sides, and then you have a different number in between. It's a very beautiful pattern in every single section, if you can see it. Yeah, you know. And you might want to memorize it like this, but that's up to you. So these are all the coefficients: 1, 6, 15, 20, 15, 6, and 1, right? So let's substitute in the numbers: AB, 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 and AB, right? 7. A is raised to the power of 6, 5, 4, 3, 2, 1, and 0. B is raised to the power of 0, 1, 2, 3, 4, 5, and 6, right? And then we just copy those coefficients: 1, 6, 15, 20, 15, 6, and 1. This is the binomial theorem, and this was Pascal's triangle. Thank you guys for watching, and I hope you understood. And as always, easy.